Okay, today we will discuss the other forms of complex numbers. So under the other forms of complex numbers, we will first discuss the roots of the complex number Z. Next, we will discuss the logarithm of the complex number Z. Next, we are going to discuss the exponential of the complex number Z. For our last topic for today, we are going to discuss the complex number when raised to another complex number. Okay, now be ready. Get your calculator, a piece of paper, and we will discuss now how to evaluate the roots of the complex number Z. From our previous topic, we can recall, this is from our previous topic. So recall that your complex number Z can be written in rectangular form as x plus jy. That is also equivalent to its polar form. Take note, this is in general polar form. R angle of theta plus 360 degrees multiplied by k. So take note, the value of k can be equal to 0, can be equal to 1, 2, and so on. Now, let's find the nth root of the complex number Z. The nth root of the complex number Z can be written as Z to the power of 1 over n, which is also equals to x plus jy, all raised to the power of 1 over n. That is also equivalent to its polar form, r angle of theta plus 360 degrees multiplied by k, all to the power of n, 1 over n. Now in this topic, now we are going to convert the rectangular form into its equivalent polar form. Take note, in finding the roots of Z, the form should be in polar form. Now, the nth root of Z can be solved using, this can be solved using, if you're going to distribute the power, that will become r raised to 1 over n, angle of, what will happen to the angle? It will be divided by the power of your complex number. So that will be the nth root. Now the first root, take note, this is nth root, meaning you have a lot of roots. By the way, k can be 0, 1, 2, 3 until you reach n minus 1. So for square root, The value of k can be 0 and 1. For cube root, the value of k can be 0, 1, and 2. Now, let's find the principal root of the complex number z. So the principal root is also known as the first root. That is when the value of k equals to 0. So if you are going to solve for the principal root, set k equals to 0. So the first root can be denoted as z1, that is equivalent to r raised to the power of 1 over n, multiply angle of theta over n. Take note, k is 0. For the second root, that is when k is equal to 1. Okay, for the second root, this is z2 equals to r raised to 1 over n, and angle of theta plus 360 degrees. Take note, k is equals to 1, so that becomes 360 degrees all over n. All right. Now, for the third root, the value of k, which is equals to 2, for our third root, we will use z3, that is equivalent to r raised to 1 over n, angle of theta plus 360. Since k is equals to 2, that will be multiplied by 2 all over n. So that's how you take the square root or the roots of your complex number z. Okay, let's solve one example here. Take out your calculator. Okay, prepare your calculator, your scratch paper, and your pen. I will be using my old calculator. So it has a centennial value. Centennial, since it's really old. So for our example number 1, we are going to find, the roots of square root of 1 minus j. So how are we going to solve this one? So the solution for this, okay, by the way, instead of just finding the roots, we are going to find and sketch. We are going to sketch the roots in the Argand diagram. Okay, find and sketch the roots of square root of 1 minus j. So what are you going to do first? You're going to convert 1 minus j to its equivalent in polar form. So in polar form, you have r and the angle theta. So take out your calculator. So this time we will convert that to polar form, shift polar, enter the real value and the imaginary value, which is equals to -1, and press enter. You now have the value for your magnitude r, that is 1.41. And for the angle theta, you have -45 degrees. Take note, we are using the degree as an angle. So you have to set your calculator in degree mode. All right, since we have the value of r and theta, now we are ready to solve for the roots. So let's start by solving the principal root. So that is when k is equal to 0. So the principal root can be denoted as z1, which is also equals to, take note of the formula. We have this general formula, r angle of theta plus 360 degrees times k all raised to the power of 1/2, since square root, means to the power of 1/2. So after substituting the value of r and k, take note k is equals to 0, that becomes negative 45 raised to, of course, the power of 1/2. Now, using your calculator, you can solve the square root of 1.41, that can be written as 1.41 to the power of 1/2. And you can also divide the negative 45 angle to. So using your calculator, what will be the square root of 1.41? So I will be using mine. The square root of 1.41 is equal to 1.19. So the square root will be equal to 1.19, and the angle, when 45 divided by 2, that becomes negative 22.5. So that will be your first root. Now for your second root, that is when k is equal to 1. So we can write that as z2 is equal to, take note r is equal to 1.41. So we can just write 1.41 angle of, so your angle theta is negative 45 degrees. So we can write negative 45 degrees plus 360, since k is equals to 1, all raised to the power of 1/2. All right. Okay, now after simplifying the values, this will become 1.19. That's the value of the square root of 1.41. And then we will divide the angle by 2. By the way, the angle negative 45 degrees plus 360 all over 2 should be written below. What will be the result? That will become 175 degrees. That will be the value of your second root. Now, after finding all the values of the roots, now we are going to sketch the roots in the argon diagram. Take note that this is your 0 degrees. That will be your 90 degrees, 180 degrees, and 270 degrees. That will be our reference angle. Since root 1 is negative 22.5 degrees, okay, that is 45. Half of that will be negative 22.5. Okay, that will be your angle negative. So negative, that is why it is below your 0 degrees. So negative 22.5. Now the root, your first root will be 1.19, angle of negative 22.5. Your second root should be directly opposite of your principal root. Now they are 180 degrees apart, and for the second root you have 1.19 angle of 157.5 degrees. So take note, why 180? Because we divided 360 by 2 and added that to negative 45 over 2. So for the square root, the principal root is 180 degrees apart from the second root. Okay? Now let's move to our second example. For our second example, we are going to, okay, for the second time, we are going to find and sketch the roots. Of the cube root. This time we are going to sketch the cube root of 4 minus J3. Okay, now your solution is to first convert the complex number 4 minus J3 to its equivalent polar form. So R here is equal to, and the angle theta is equal to, okay, take out your calculator and try to convert the rectangular 4 minus J3 to its equivalent polar form. So you can write that as pole 4, comma, minus 3, then press equal sign. Now you have the value of your R and your angle 36.87 degrees. We will be using, all throughout the topic, we will be using up to 2 decimal places. Okay, let's solve for the first root. The first root, that is when k is equal to 0. I will not be using the formula anymore. I will not be writing the formula, but rather the magnitude and the angle, 36.87 negative, is raised to the power of 3. Okay, by the way, that is plus 360 degrees times k. That's the general form, raised to the power of 1/3, since we are looking for the cube root. So after simplifying it further, that will become 5 to the power of 1/3. Take note, k is equal to 0. So what will remain there is negative 36.87 all over 3. So cube root of 5 is equal to 1.71. Take out your calculator. And negative 36.87 divided by 3 is equal to negative 12.29. That will be our first root. Now for our second root, now that is when your k has a value of 1. So this will become 5. Now we will write 5, angle of, we will write also the angle, negative 36.87, but this time the value of k is equal to 1. Okay. Okay, we will raise that to the power of 1/3. So what will happen? If you are going to distribute the power, that will become 5 raised to 1/3. And the angle inside will be divided by 3. 36.87 plus 360 degrees will be divided by 3. Therefore, your second root is equals to 1.71. That is the same above. Angle of, take out your calculator and then compute negative 36.87 plus 360 degrees all over 3. That becomes, okay, that becomes 107.71 degrees. All right. Now for the last root, we will name that as the third root. Okay, that is when k is equal to 2. So we will denote that, no. Okay, by the way, 5, that will become your magnitude. Copy the angle plus, take note, k is equals to 2. That will become 360 all over 2. All over 3. So I have distributed now the power. So that becomes 1.71 angle of, okay, try to compute that in your calculator. So that becomes 227.71 degrees. Okay, now that will be my third root. So for my third root, now we are going to, after finding all the roots, we are now ready to sketch the roots now in your organ diagram. Okay, let's denote this as Z1 as your first root, Z2 as your second root, Z3 as your third root. Okay, plot the principal root, that is Z1, negative, so it is below your 0 degrees, negative 12.29 degrees. Now your next root will be plot next, that is Z2 is equal to 1.71 angle of 107.71. That will be your Z2. Take note of the angle between the roots. The roots now are 120 degrees apart from each other. So that will be your second root, 1.71 angle of 107.71 degrees. Now for your third root, you have Z3 equals to 1.71 angle of 227.71 degrees. Take note, they are also 120 degrees apart from each other. So why 120 degrees? So for the cube root, the roots are 120 degrees apart from each other. That is because if we are going to divide 360 degrees into 3 equal parts, that will result to 120 degrees. Okay. Ayos. This time, you are going to solve the problem. Take out your calculator again. This time, you have to work independently. So I will give you 20 minutes to solve this problem. All right. This time, we are going to find and sketch the roots of, okay, we have the fourth root of 5 plus J7. So that is the fourth root of 5 plus J7. So you will be given 20 minutes only to solve this problem. Don't forget to pause your video. Pause this video for a while and then try to solve the problem. All right, here comes your answer. So for the fourth root of square root of 5 plus J7, the distance or the angle between the roots is equal to 90 degrees.